So here we are at InventX. Now we're going to take a look around the lab and hopefully have a chat with some of the researchers. Let's go.
If you're an SME and you have a low carbon idea that we can try and tweak, whether it's a product or a service, then we can maybe help you fund that particular area. We're in it for like a long-term relationship side of things. You know, we're not in for just a transaction and then move away. A lot of the businesses that we've worked with over 2 years, very much a part of what we're looking to develop with them and grow with them as a business in terms of, you know, we can work on one particular project, but as we move forward, then that project could move into 5 or 6 different areas across different faculties with different impacts. We've got this access to over 1,000 academics and over 16,000 students. A company could come to us and say, can you develop us a software app? And we said, well, a lot of people in the commercial environment can develop software apps, but if you came to us and said, can you develop an algorithm within the software app, which means it can do this, then suddenly that's a different ballgame. We can help startup businesses, early development stage businesses, and all the way up to like corporate R&D research teams.
What better place to start at the Aura Innovation Centre than at the home of augmented reality, virtual reality, and CAD design. It's the digital zone.
So I'm the computer-aided design technician here at Aura Innovation Centre. So my role is to design parts, components, mechanisms, sometimes other 3D models for different academics.
What are the benefits of, operating and making models and creating world spaces, in VR?
The main positive is that it's a form of rapid prototyping. We can produce these parts, these machines, without having to make them physically. So we can test these in the virtual environment, as well as viewing them, and also showing our clients what it looked like before we start actually putting this into production. Okay. So it's a lot cheaper for the client, right, and they can understand exactly how it's going to go, so we don't make any mistakes when we're in the manufacturing process.
I'm curious to see what's going on here.
Yeah, not worried. So it'll be on the big screen there. So I'll just go virtual, as I always say. It's a very basic human body, and then we can pick up this heart. We can have a look around with it, pick it up, can look at it, get a good inspection of it, and then put it back in. VR is just so expansive, like it can be done with anything, not just surgery. We could create a training software where you don't even have to leave your home to like go to an offshore wind turbine.
You're definitely selling it to me. One more question.
Yeah.
Can I have a go?
Yeah, of course you can.
Well, if you thought that was fun, now we're going to have a look in the advanced material zone. Let's go. So, Ellis, tell us, what goes on in this room and how does it involve your job?
What goes on here is we do a lot of testing on materials and products in this room. So that's a leaf, and then the rest of it is a tea bag. So you can see that the tea leaf won't escape the tea bag because the holes in the tea bag are too small for the leaf to escape. So we can do this quality assessment of materials in this room and check that your material is actually fit for purpose. This is fractures. So here we're looking at a fracture, a microscopic fracture in a solar panel. We have lots of solar panels here at the AOC, and this is just one of them. And we can do this investigation on loads of different materials. In this zone as well, we not only look at stuff microscopically, we also look at materials and how they react and interact. So we work with companies on oil formulations, on soaps, on lots of different formulations.
We've got Jim Gilbert here who's going to explain what a composite material is.
A composite really is just something where you combine 2 different materials to get the best out of each of them.
Okay.
So the kind of stuff we're looking at is wind turbine blades. And so they're made out of glass fibre, which is very strong, but obviously very flexible.
Okay.
And then you put that with some resin and you make something that's much more solid and rigid.
Okay. Yeah.
One of the things we're interested in is trying to improve that process, make it faster, and improving the quality. If you imagine you're making a huge wind turbine blade, if you get a defect in that, it's very expensive, very difficult to repair. So what we're trying to do is understand the process better so that we can avoid those faults.
Right.
And what we do is put fibre optic sensors into the mould as it's being formed, and they can detect the resin as it goes into the mould, and that can tell us how that process is getting on. We might put 10 sensors into this one. In a full-size blade, you might have hundreds of sensors.
Right. All right, and now we're going to explore the green energy zone. And I'm talking to Dr. Zishang Zhu.
So what we're doing here is basically we work on two types of technology. The first one is the renewable energy, which is generate energy or generate heat without using fossil fuel, of course. The second type is to use energy more efficiently, like we use air source heat pump or we use dew point cooler to generate heating and cooling to use less energy. Right. So the most exciting part of our experiment is the solar simulator. We call it the solar energy test rig. We have solar panels, PV and solar thermal collectors, and we have, as you can see, we have very big solar simulators, which will basically simulate the sun. It will provide sunshine to the panel surface, and the panel will generate electricity or generate heat. And we can store the heat in the water tank to simulate the whole process of a household heating system.
Honestly, you guys, you need to see this. They've literally got the sun in a box. So we've got two types of renewable energy you've been testing on. It's solar and it's water. Why is this important? Why do businesses need to start thinking more about these two forms of energy?
All we know, we need to reduce the carbon emission, and the UK has already set the net zero carbon emission goal by 2050. So all the business, including building sector, are under big pressure to reduce their carbon footage. Combine two technologies together, we can say we can cover almost 80 to 90% of the hot water use by using renewable energy.
That's incredible. So Reece, can you tell me a little bit about yourself, what you're doing here, how did you get involved with the Aura Innovation Centre?
I'm a research, development and innovation project leader here at the Aura Innovation Centre, working within something called a knowledge transfer partnership. We use something called a novel electrochemical route to actually destroy the pollutants within the wastewater stream. So we're using a branch of chemistry called electrochemical engineering or electrochemistry, the renewable electricity from wind-derived electricity, for example, to actually drive the process to improve the condition of their waste streams.
So if I get this right, you can use renewable energy to power this type of energy, which itself is renewable, to get rid of waste energy, is that right?
Pretty much, yeah.
This be the next big step in businesses, big, medium and small, becoming more environmentally friendly?
Potentially, yes. The application of the technology isn't just limited to the company I'm doing the work for. It could potentially be applied to a number of different waste streams, really.
So, we've all seen a circuit board before. Well, welcome to the printed circuit board zone. Dr. Chun Keat Yu is going to take me through everything that he's doing.
Thank you, Kofi. So Flood Innovation Centre is a sister brand to the Aura Innovation Centre. So they're very kind to allow us to share the facilities that we have here. It's an amazing facility.
Hull is underwater by 2050. We come find you and say, what happened? Is that what?
I think a lot of people don't realise the Yorkshire and Humber outside of London is the second highest risk for flooding.
Wow.
So a lot of people really don't realise that. And I think there's a lot of business opportunities and a lot of markets.
Printed circuit boards.
Absolutely.
This is your field. We've got some wonderful, I want to say bits of metal here, but can you take us through, printed circuit boards? We all know what circuit boards are. They're in our phones, in our cars, in our cookers. I mean, they're everywhere. But how do they interact with you and your work?
Absolutely. So this is our PCB section within the workshop. And so I'm going to take you through quite a quick process of being able to go from completely blank piece of copper all the way to, you know, something like this, something tiny like this. This guy here with the machines that we've got, you can take from this guy straight away onto essentially this. So it includes all the drilling, all the etching, all the tracks are all beautifully made. So you can then do double-sided. It can even cut it out for you completely. For example, if you're making a new product which then uses electronics of somehow or some kind, even electrics, you know, like relays and so on, just switches and so on. So you need electrical tracks, you need electrical circuit boards, right? And it's very expensive to mass produce a design, a specific design, especially when you're testing. So it's a lot cheaper and faster to get these prototype. You know, we can make 1, 5, 10 bespoke designs, and we can then iterate it, you know, on very, very quick timescales, days instead of weeks or months. So you can then get your designs out to market a lot faster. Speed is everything. Time is money, right? So
yeah,
it's crucial for SMEs.
And these guys, the hardest workers in the building, they never sleep. This is the 3D printer zone. So how can 3D printing help businesses then? What's the benefits of it?
The benefit of 3D printing is that there's a lot less wastage against traditional materials. So traditionally you get a block of material, mill around it, waste a lot of material and get your shape. Here, you actually build the shape from the ground up exactly how you want it. So it comes off the 3D printer how you want it. Here we've actually got a company that I really want to show you. They've given us this piece here, which is their metal tool piece. So that's been manufactured away over the bridge. But what we've done is actually 3D printed it in metal. So if you picked up both pieces, you could tell the weight difference. The tool piece is a lot heavier and the metal 3D printed bit is a lot lighter.
Is that this one there? Yeah.
So that's like very heavy.
Yeah.
Then pick up the metal. Because it's hollow inside, because we can make gaps inside. So it doesn't need to be a full solid piece of metal. But it's still got the same structural integrity as the metal.
So with it being lighter, would that mean it's cheaper to export them?
In bulk, it's a lot lighter.
I'm pretty sure these are metal, right?
Yes, yeah.
So anything can be 3D printed.
Anything
pretty
can be
much.
3D printed,
Yeah.
and also the material can come from anything. So here we like to use a lot of waste material. So we've got waste PLA, which we use to print with. But you could also use bottle tops. So we've actually been collecting our milk bottle tops here, and we're going to create a 3D printed filament out of bottle tops.
Right. But no, Ellis, thank you very much. That was fantastic. Cheers. I have to ask first question, where do we go from here? What is next?
The thing about the Aura Innovation Centre is it's about getting involved. You know, you've got ideas, reach out. This building is about the people that come into it and about the people who work here and the people that sit behind it, how they can solve your problems working together, how you can meet and collaborate with other companies. You know, you've got an idea and you really want to drive it home, but you don't know where to go. And this building as well is a real asset to the region. That knowledge transfer about we're here and we're open.